This is propane. But what exactly is propane? Where does it come from, and how does it relate to gas laws?
Propane is a fossil fuel that is found alongside gases such as ethane, methane, butane, and other hydrocarbons. When these natural gases are processed and refined, you get propane. The chemical structure of propane is 3 carbon atoms connected with 8 hydrogen atoms, or C3H8. It is a hydrocarbon and alkyne gas. For storage, propane is isolated through refrigeration or distillation, and then pressurized in order to be stored and transported. When the liquefied propane leaves its storage tank, pressure drops and the propane returns to a gaseous state. So, how did we first find and utilize propane? Propane was synthesized by a French chemist named Pierre-Eugène Marcellin Berthoult in 1857. However, the gas was never seen or utilized as potential energy until 1910 when Walter Snelling labeled propane as a volatile substance in crude oil and began manufacturing it for mass markets. Now, propane is used for a multitude of goods, such as grills, water heaters, and fireplaces. After all, when most people think of propane, they think of common household appliances. But propane also has uses in industries like agriculture, manufacturing and warehousing, refrigeration, hospitality, and transportation.
Now that we know what propane is, the question is, what are the gas laws that relate to propane? Propane is 2 gas laws that relate to it, Gay-Lussac's law and Boyle's law. Gay-Lussac's law states that gas's pressure is directly related to its temperature with the formula P1 over T1 equals P2 over T2. Boyle's law states that pressure is inversely related to volume with the formula P1 times V1 equals P2 times V2. Now, how exactly do these laws relate to propane appliances? Boyle's law relates to propane gas because as you decrease the volume of the container propane gas is held in, the pressure increases, which is why propane gas is kept in high pressure in order to minimize the volume needed to contain it and maximize the amount of propane that can be stored in a small container, which saves money and space when transporting propane and makes it overall more convenient to handle. Gay-Lussac's law relates to propane appliances because as propane is heated, the pressure of the gas is directly affected, increasing as well. This is why it is so dangerous to leave propane near heat, since if a propane tank is left near a heat source, like a flame, it could heat up to the point that the pressure is so great that the gas in its container explodes, which is why propane needs to be stored on flat ground that is not flammable, with no flammable or combustible material nearby.
Thank you for watching our informative video on propane appliances and how they relate to gas laws.
We hope this video helped you better understand how Boyle's law and Gay-Lussac's law play a crucial role in the safe and efficient operation of propane and propane appliances.